In this example, we are going to solve exponential equations, and the bases are not the same, and they cannot be transformed so that they're the same. So we have 4 to the power x minus 1 equals 3 to the power x. And you can see that 4 and 3 do not match. So you can just equate the powers. The usual trick here is to apply log to both sides, and you can use the common log log, or you can use the natural log ln. It doesn't matter, so I will use natural log. And I'm going to use its one-to-one properties to see if I can solve this. Okay, the next step is to use power rule of the logs. And what that does is that you take the power and you can bring it to the front of the log. And take this power and bring it to the front. Now we do have to put the left-hand side, when we put x minus 1, we have to put it in parentheses because that's the whole power. Okay, so this is going to be x minus 1 multiplied by natural log of 4. On the other side, we're going to get x multiplied by natural log of 3. By the way, never try to separate it. Like natural log of 4, even though it seems like a fancy thing, it's just some number. Okay, so you cannot mess with it. Now we have a problem because we have variables on both sides. We have x times some number times some ln of 3. And then we also have x minus 1 times ln of 4. So here's what we will do. We're going to distribute that log of 4 to both terms. Okay, so what will happen? So first we're going to multiply ln of 4 by x, which you cannot simplify. You can just say ln of 4x. Minus, then we're going to multiply natural log of 4 and 1, but multiplying by 1 does not change anything, so that'll just be natural log of 4. And on the other side, we still have x times natural log of 3, and we cannot do anything with that. Now, we can see that we have variables on both sides. So one of the sides should be the variable side, and one of the sides should be the number side. So here I have natural log of 4 times x, and here I have natural log of 3 times x. What I will do is subtract in the natural log of 3. I'm going to write it in front just so that they line up. So, okay, and then I will subtract it here. What will happen? It will cancel on the right hand side, which means that there will be 0. On the left hand side, this you can't really simplify other than factor out the x. So you can say that that's natural log of 4 minus natural log of 3, and that's multiplied by x. Okay, and so just think of it as like 5x minus 3x equals 5 minus 3x. Of course, it's not 5 and 3, it's some natural log of 4, natural log of 3, but that's the way that works. Okay, so that was just an example to see why that happens. Okay, and I still have minus natural log of 4 over here on the left-hand side. Now I have the variable x on the left-hand side, but ln of 4, which is a number, even though it's a fancy number, is still on the left-hand side, and I do not want that. So I would need to add natural log of 4 to both sides. Okay, what that does, it'll cancel it here. And here I have natural log of 4 minus natural log of 3 multiplied by x. And that's going to be equal to 0 plus ln 4, which is just ln 4. Finally, whatever this thing is, I will divide both sides by it so that it cancels. So at this point, if you want to, you can put this on a calculator, but I will not. I will still leave it as ln of 4 minus ln of 3. So I'm dividing this whole thing, and I'm doing the same thing on the other side. By the way, this can be simplified using another rule of the logs as log of 4/3, but you don't have to. Okay, so now let's cancel this part here, and now let's put that on a calculator. And I've got ln of 4 on the top. On the bottom, I will get ln of 4 subtract ln of 3. All right, so this requires 4 decimal places. So let's just say round and answer to 4 decimal places. Okay, now Before I submit anything, I do want to check to see if this is really the right answer. So I will plug that into both sides. So I'm going to put 4 to the power, whatever that x is, subtract 1. So that's one side. And the other one is going to be 3 to the power that x. Now you can see that the answers are slightly different, but very close to each other. And that happens because I rounded that whole thing, right? I rounded it to 4 decimals. But overall, I can see that they're very close to each other. So I'm hoping this is right.